So let me know if you folks see my screen. Yep, okay. So hello everyone, welcome to the data engineering meetup, data engineering Melbourne meetup to be precise, but in this world, yeah, it's yeah, if you are in any part of the world, you're most welcome. It's yeah, it's for everyone. So today, oops. So today, this is the agenda. Welcome, and today Jag is going to talk about Apache Druid, and so I'll let Jag talk about it more. I'll not talk about it, but then we'll have community marketplace. Community marketplace is more about if you're a recruiter or you're anyone who has a job to offer, you can use this platform to share that opportunity, and or if you're looking for a job, you can also use this platform to share what you're looking for. If you have anything else like open source which you want people to work on, or maybe any conferences that you would want to share about, please feel free to do that. So we'll do that after the talk. So without a further ado, I'll hand it over to Jag for the talk today. So.
All right, thanks, Harmeet. Hi, everyone. Let me share my screen and then we can get this going. Okay, so, all right. So I take it everyone can see my screen. Great, fantastic. So today we will have a chat about, Apache Druid. The tagline here is lightning fast analytics on real-time and historical data. So I'm Jag Dillon. I'm a senior sales engineer at Imply. I'm based out of Sydney, Australia. And basically, since hopefully you guys are from all over Australia or all over the world, I know there are people from the UK and Croatia on the call and a lot of people from Melbourne. So we'll just go and talk about Apache Druid. So a bit of introduction and some architecture use cases on where we are used, a bit of history, and then some question and answers at the end. Now, let's talk about data challenges affecting business. I mean, we are in July 2021, February 2020, the whole world changed. And for the past year and 3-4 months, past 15-16 months, we've been working from home, working virtually, working remotely. Everyone's gone, people were going digital prior to that, but the last 12 to 15 months just accelerated the journey. And what do we have? We have a huge amount of data, right? That is being generated by all sorts of systems. So everything's gone digital, thus the data that is being generated is accelerated. So everyone is struggling to keep up with this data. So, if you're in a data engineering team, I reckon if you're working for someone, you're having a similar challenge where, everyone is looking at data. They want to see data in real time. They want to make decisions in real time. Because it all as things are changing very quickly today, with how things are changing. For example, like we go into lockdowns every now and again in Australia, and it's not fun. But business wants to see how that impacts their businesses, whether they're running it online or in person, and they need to make decisions based on this data. So users need to have results. They need to have answers. They need to be able to make decisions faster, and they need this at the tip of their fingertips. So having a big challenge with data, we have come up with Apache Druid. So what is Apache Druid? Apache Druid is a high-performance, real-time analytics database that's written on the website druid.apache.org. It's a high-performance, low-latency, high-concurrency, ultra-fast query execution on large and very large data sets, right? What we mean by that is super fast. When you need information at the tip of your fingertips, you need it fast, right? And you need to be able to get it in real time, right? You need to be able to get, when events are happening in real time, you want to be notified, right? And you want to be able to compare that to what happened today, to what happening right now, as we are speaking right now, to what happened an hour ago, what happened 2 hours ago, what happened a week ago. That's what everyone wants to have. So imagine having a system that can handle all the loads, not from one user or 2 users, but from a lot of concurrent users, whether it's in your business or in your organization, whether it's internal or external, right? So Apache Druid is a high-performance, real-time analytics database. That's what we are, right? Now, let's talk about the engine behind Druid, right? Apache Druid ingests data, and it can ingest the data whether it's coming via streaming or via batch. Streaming, if you're talking about, information, if you're using a streaming technology like Kafka or Google PubSub or Kinesis, or one of the others, Azure Event Hub, we have ready-made connectors out of Apache Druid, which you can just connect to this streaming data, and we will index this data in real time, right? Or it could be batch data, right? You might have historical data in one of the cloud storage systems or Hadoop storage system, or your data warehouse could be on-prem, on the cloud. We can index both streaming and batch into Druid. And then what you get out of it is you can run SQL commands, right? If you want to run SQL commands on your own, right? And then you can feed that into a user interface, right? And the user interface will come up with results, which can help you with business applications, right? Business applications where performance is important, right? Where scale is usually large, right? Where it's, and most importantly, it has to be self-service. What we mean by self-service and interactive is that we want the users to be able to go and slice and dice the data themselves, rather than waiting for an analyst to modify their dashboards, right? They want to be able to do this on their own, right? And they also want to be able to have further drill downs, not just a visualization layer, but they want to drill down further so that they can modify the analysis by changing it themselves, right? And it's open for both internal or external users. So that's what Apache Druid is all about. Now, the key features of Apache Druid is that it's fast, right? It's low latency ingestion. Thus, as the data is happening, that's the reason why a lot of users of Kafka or Kinesis, they have Druid in their solutions, right? In their data platform to handle all of this real-time data, right? And then it is resilient. So you do not want to lose data, especially when there's business data involved, right? You can imagine how your business will be upset if your data solution can't handle it, right? Or it goes down. Security, that's also very important. Druid is secure. There's user authentication and authorization. Scalability, right? You want a solution that can handle from petabytes of data to from terabytes to petabytes of data, right? It has to be flexible. It has to have dynamic schemas. It has to be able to tier, because you don't being scalable is one thing, but you also want to make sure it's cost effective, right? And it has to be able to handle simple data ingestion, whether it's batch or streaming, right? That is key, right? And of course, last but not least, you need to have easy access, right? Whether is it via SQL commands, whether to or user interface, or to connect to existing BI tool that you might have, like a Tableau. You want it to be able to support all of that, and all of that is part of Apache Druid. Now, as I go further, where does Druid fit, right? So you have cold data, right? Cold data is basically where where the response time can be minutes, hours, or days. And you have complex reporting queries, right? Latency is not important. And usually you will have a few data analysts working on it, running some heavy-duty SQL commands. What is hot data? Hot data, on the other hand, requires very quick response. That means when it's not designed for it's not designed for one or two users, it's designed for a lot of users. So remember when I said for both internal or external users, thus you might have a lot of concurrent users, a lot of users who will be expecting to look at the results immediately, right? A lot of interactive ad hoc queries, right? A lot of, and then latency is extremely important, right? Simple example, every one of us has a mobile phone. Every one of us has a bank. Every one of us will go to a banking app and just take a look what's happening in what's my bank balance, where am I spending my money, right? That's an example of hot data. Imagine if you have your mobile app, banking app, and you click on it, and it takes you a few minutes. You're like, I don't have time for this. Everyone wants the answers quickly. That's hot data, right? And you can imagine there are hundreds of people who are connecting to their banking app at any one time. So you want to have a database that can handle that amount of users and provide that information out to them in a very, very timely fashion for hot data. Then, of course, in between, you also have the warm data, right? Where users require a response. Usually it's, about under 30 seconds, right? And there's a mixture of ad hoc queries or dashboards. Latency is important, but not so important. Imagine you're a mobile company, whether it's in Australia, it's either Telstra or Optus or Vodafone. I can't think of anyone else, but it's one of these three. And you will have your your mobile provider's app on your phone. You want to see how much broadband you're using, right? And when you click on that, that's an example. When you click on that, you also have information about your account, the type of services you're subscribed to, your monthly billing, how much data, how much usage have you done. That's another example where latency is important too, but it doesn't require to be, quick response, because you're like, I'm just interested to see. Sometimes, if you're on, sometimes it takes a while for you to update, but that's warm data. These are areas where Druid comes in very, very useful. So if you've got a scenario where you need to provide interactive ad hoc queries where latency is extremely important and you want to have sub-second response, under 1 second or under 2 seconds, then Druid is the solution for you, right? Even if you want to have something that's warm data for warm response. For example, if you're having a business and you're providing a SaaS solution, and that SaaS solution, you have customers. Customers, again, could be internal, could be external, and you want to give analytics on the type of business services that your customers are getting from you. You want them to be able to run their own queries, own dashboards. Latency is important, right? That's where Druid comes to you. So that's where we see Druid as a fit. Now, the typical use cases of Druid basically can be, anything that has got instant data visibility, right? Ad hoc queries, operational analytics, high concurrency, right? So again, something that requires fast response and has got a large number of users at any one time, right? So it could be any of these industries, from the risk industry, in the banking world, or in the fintech world, manufacturing. I'll explain further. I'll have some slides later on to talk about some of the users of Druid out there. Network performance, user behavior analysis, clickstream, right? Digital ads, real-time data warehousing, IoT. This is the type of data that is happening as we speak, and it is growing very quickly, and it's got a lot of users. That's where the use cases are for Druid, sweet spot for it, right? And this is what we have found out from the market. Most popular use cases for Druid: digital advertising, user behavior analysis, right? Web mobile and analytics. Digital advertising is where Druid was formed. I'll talk about the history shortly, but digital advertising, as you go to a website and you can look at the amount of digital ads taking place, those companies that are actually advertising, they want to see how effective that is. And you can imagine they want those answers in real time. But not just those people, you also might have security companies that are providing security services to these companies, for example, to ensure that they don't get spammed or they don't get DDoS attacks against their ads, because you never know. There could be people who are not happy with a certain brand and they want to attack them on the market. So security analytics company too need to have that visibility. And then you have the IoT devices, the network telemetry. So the bottom line is, basically anything that requires a lot of data in real time, and you have a lot of users who need to respond to it. And this is what the survey of Apache Druid users out there has come back with us. Now, the history of Druid, this is where we started. Druid was created at Meta Markets, which is now part of Snapchat. Meta Markets provides analytics to buyers and sellers of programmatic advertising, right? And the use case was to analyze programmatic advertising data. We're talking about billions of events per month, right? And they had 30 plus dimensions. Think of dimensions as fields, right? And add impressions and click data. That was the key use case. They wanted the users and ad engagement to be optimized. So they had to design for a very granular, right? Where the time scale was very, very right down to the seconds. ad hoc queries on many dimensions, right? So here's an example of a query. How many users will see an ad targeted at female executives aged 35 to 44 from the US, UK, Canada, reading sports blog on weekends? This is the type of queries that the customers who were advertising on the platform provided by Meta Markets were demanding. So Druid was created to allow users to answer this type of questions. Before they came up with Druid, they were looking at alternatives, right? Everyone wants to have a quick solution. Why should someone work too hard? If something is out there, I'll just modify that and use it for my solution. So they went down the traditional relational database. The challenge with that was the scan rates was too slow, right? When you have billions of records or even millions of records, millions of rows, it was such a challenge. They tried caching that. That didn't help because as the users start drilling down, it was still taking forever, right? Updates were triggering row and table locking. That didn't help. The schema was rigid, right? The users could not, modify as they wanted, as they changed the pattern behavior of the users to see how the ads would behave, how the results would appear based on different scenarios, right? NoSQL, right? They tried with that. High latency from event arrival to query availability, right? But the challenge was there was a lot of time required for pre-aggregation of data. And that was taking hours of processing time, which was delaying them, right? Processing time grew exponentially as new dimensions added. So that didn't work either. They went down the time series databases. It was high cardinality dimensions, which was causing performance bottlenecks, but they were using time series database. At the end, they went up with OLAP, right? But neither of those solutions out there was able to deliver what they were after. Thus, they came up with the word Druid, and they came up with the Druid database. So if any of you followed this show in the 80s and 90s called Dungeons and Dragons, the Druid is a wizard. The wizard can do everything. It's a magician. Thus, that's where the name Druid came from. Our founders came up with the word Druid for this particular database. It is low latency. It can handle the best of time series, the best of OLAP, and the best of search. A hybrid of all three, the best of all three, right? So they used all the features from all three and came up with Druid, the magician. The community, it's been around in the open source community in the Apache Software Foundation since 2012. It got promoted to the top level Apache project in 2019. It's not that long ago, only 2 years ago, right? They've got 30 plus committers from 15 plus organizations out there, right? And there's about 300 plus contributors from over 100 plus organizations. And there's a list of growing companies that are using Apache Druid, right? Over here, it says 1,000 plus, and it's growing in popularity as data grows and as real-time requirement increases. These are some of our production users. As you can see, we have got a lot of popular brands in there, right? You will see Cisco is there twice because Cisco has got 3 different divisions within Cisco which have their own Druid environments, right? Here in Australia, we have Atlassian, right? They are using Druid for their Confluence product to power the analytics of Confluence. We also have a very interesting Druid user here in Australia in a small town called Newcastle, where it's called Switched In, as you can see over here, Switched In. And these guys are helping customers who have got solar panels on their roof. Like most of us in Australia, we have solar panels in our roof. These guys help you provide analytics in terms of see how much data, how much solar power, how much energy is your solar panel creating. And you can, as a user, by subscribing to Switched In, you can see how much your generator is creating a day on a certain time. And you can see how much it's being sold to the market, to the energy providers, and how much money are you getting back. That is powered by Apache Druid. And these guys are really cool. They're based, because it's a small town called Newcastle here in New South Wales. But of course, apart from that, you have all these others out there. In this part of the world, Alibaba Group is one of our largest Druid user. If you go to China, they've got like up to about 500 Druid users in running on Alibaba Cloud. And then of course, you have the Netflix, which I'll go into in detail shortly. But these are some of the brands. And what you'll notice is it's always the technology companies that adopt a new technology before the rest of the market picks up. So as you can see, there's a bulk of technology companies in there on this slide here. Now,
sorry, Jack, to interrupt. There are a couple of more than a couple of questions in the chat. So would you like to address the questions in the end, or
yeah.
In the end? Okay.
Yes, thanks. Now let's talk about the architecture, right? Think about the core concepts, right? You will have here's an example of an event that takes place in your business, right? You have the time, you have the page ID. This is a clickstream event. You have, the time the event takes place, which page was on your website did it take place, the user ID, for example, there could be a authenticated user, the load time. All that events are being ingested into the Druid server, right? And the Druid server will have a data source, right? In this example, it is clickstream, right? This data source is like a data container, similar to a table in our RDBMS system, right? And it breaks down each of these rows by segments by time, right? And when I say time, basically we're talking about right down to the microsecond level, right? Or you can group them together if you want to. We have something called rollup, but that's an example of how Druid is ingesting the data, right? And then you have within Druid, we have something called deep storage, right? Where it's all the segments, which is from the data that you have indexed. These segments are stored in cold storage because, as you can imagine, the amount of data just grows and you want to make sure it's cost effective. So you can use cheap storage like S3 or Azure Blob Storage or HDFS or even network file storage if you're using on-prem solution to maintain this data, right? And then you have the metadata database. Metadata database tends to run on, either PostgreSQL or MySQL, and all it does, it just has configuration updates about your servers within Druid, right? The rules, the tasks, the server names, all of that information is stored in the metadata database, right? And then you have a scalable architecture where you have a number of services, where you have the query broker, right? And then you have the indexes. So the events as they are being generated are being ingested with the indexer, and the historicals is where the data which has been ingested is stored, right? And the query brokers is when the users are connecting to it to run their queries, right? And these queries are either coming in via SQL or JSON, and they are running via their own user interface, right? And the results are returned there. Each of these scales independently, right? And the query engine is built for speed, right? So you can see, newly ingested plus historical data, you have the middle manager, right? The middle manager basically ensures all the data is going in the right direction, right? And the query brokers will be responding to one of these. And the users, as they're connecting, they're getting the response very quickly. That's pretty much the query is performed on the data nodes, right? And the query engine determines which nodes are serving segments that are involved. So sometimes, you might have historical data which are sitting in a cold storage, but it can have dedicated lanes to that data depending on how often. So this is part of the whole architecture of the Druid solution. And this is a summary of it, as you can see, right? You have the source data coming in, as we spoke about the events, whether it's coming in JSON or CSV or TSV, Avro or Parquet. And then, most of the time, if it's streaming, it's coming via Kafka or Kinesis. And then you subscribe to the topic, and then Druid indexes it in the data nodes in the middle managers. And here you have down here, you have the users who are connecting via their web user interface, or they're running via JDBC. And that will link up to the Druid server, which will be handled by the query brokers, which will send the request to respective data nodes, whether it's historicals or the middle managers. That's a high-level architecture summary. It is distributed and it is scalable on a horizontal way. Now let's talk about real-world use cases. Remember, we mentioned about how we can be used for a lot of different use cases. You have companies like, who are in the risk fraud, like DBS Bank here in Singapore, right? You got supply chain manufacturers, you got network performances. So these are some of the use cases. What I'll do to conscious of time, let's go into Mopub. Mopub is the company owned by Twitter. It is provides monetization solutions for mobile app publishers and developers. So for example, if you are a customer of Meetup, which is Twitter, and if you're a Twitter user, notice when you're going through your tweets, you will notice some ads, right? Those ads are done by the publishers, right? They want to see how effective are those ads. Thus, as you can see, right, you are the user, the ads are being published to you by the ad server. And if you click, they want to see how responsive it is. It goes into imply Druid, and the customers of Meetup will connect via, in this example, with imply pivot. By the way, imply is the company behind Druid. Druid is the open source solution. Imply is the company I work for. So as usually anything, you have the open source solution and you have the premium solution. So the premium solution is Imply. So by numbers, right, you can see they've got like 13 months of raw data, right? And it enables the advertisers to check year-over-year comparisons. That's like, they've got like 52,000 apps running on the Twitter Meetup platform. Monthly, they've got like 1 trillion ad requests coming in, right? There's 30 billion ad requests every day. So we're talking about 150 terabytes of raw logs. They are having a Druid cluster of 1,000+ nodes, right? And these guys are just growing every year, right? As you can imagine, everything is about digital. And you can actually read more about Meetup by going onto their website, where it says, that's the address there, developers.meetup.com. And in there, do a search for Meetup Analytics, and they actually have videos showing you how Meetup Analytics run, and all that is powered by Druid. Netflix, they are one of our earliest adopters of Druid, right? So when Druid was first released in 2012, Netflix adopted it. As Netflix was rolling out Netflix across the world, they wanted to see how the users were responding. So as you can see on here, you have the users' TV or their iPads or the laptops, etc. They are connecting and they are viewing Netflix. The logs are being sent to the log API server, which goes to a Kafka log topic into the Netflix cloud, which goes into Druid at the end for their real-time analytics, right? So they were able to see, for example, some of the use cases would be to do with capacity planning. They were to do with, as they're changing the Netflix applications, the versioning, payments, right? It's a number of use cases, anything to do with the users, how you and I watch Netflix at home, as our behavior changes, all of that is being analyzed using Druid, right? So that's an example of user behavior analysis at Netflix. And as you can see, they've got so many different use cases, right? That's how adaptable it is. Ultimately, it's as good as your data, and whatever your data source is, it comes down to real-time and a large scale and a lot of users, whether it's internal or external. eBay, they are using us for an APM use case, right? So you have their apps that are used, right, in real time internally, right? You can imagine, right? Because they've got a lot of online business, so they have a lot of internal apps that needs to be running 24/7. Performance should be running. They have got more than 5,000 applications, right? And they need to have less than 10 seconds latency from event generation to realization. So you can see how much data is being handled via the Kafka streams into Druid. And then the users are connecting via egress to see how the applications are performing. They can slice and dice. They can see if there's any anomaly, root cause discovery, if there's any performance comparisons between A and B as they're rolling out different versions. So that's eBay, right? Large electronics company in, can't mention the name, but these guys, they are ingesting sensors from their manufacturing plants, and they're reporting real-time data to centralized Druid clusters. They are using it for production efficiency, right? Previously, they were using traditional RDBMS system. It just couldn't handle. It was taking forever for them to correlate reports from different manufacturing plants. And these guys are one of the largest manufacturers in the world. And today it's all being handled via their Kafka streams into Druid in a central location. And now they have a consolidated view across all of their factories. They can see via real time how each factory is performing in terms of the supply, manufacturing, right? And they can see if there's some problems, where the problems are occurring. They can make decisions much faster. And they can also ensure if the products are getting defect or they are, they have some problems with manufacturing, they can actually immediately pinpoint that these items with these serial numbers from this plant are considered to be defective. So if anyone bought those products in the black market and then comes to try to claim warranty, their customer service staff can actually connect to the Druid solution to check by seeing if this product is one of those items sold in the black market, and they can reject that warranty claim. So that's an example of a large electronics company. Walmart, right? They are ingesting data. As you can imagine, Walmart is in fierce competition in the US with Amazon, right? Similarly here, in Australia, we have Amazon is also coming to the supermarket chains too. They are all getting worried. So Walmart was having a challenge where they wanted to know how the inventories were selling based on different stores, based on different geographies, and based on the type of items that were selling. It used to take them a month, right? Because you can imagine the amount of data they were using. They had a large Hadoop ecosystems with Hive, with Presto, and the queries would take hours to complete, right? Today, they are getting the results within seconds, right? Today, they can immediately pinpoint if a six-pack can of Coke is selling badly in a certain location compared to a 24-pack can of Coke. And they can even prioritize their inventory so that they order the right items to the right location, and it sells at a better rate based on just looking at imply for inventory analytics, right? And that's just one example. They also use, Druid, and they're also using Druid for, to look at from a flight deck perspective, where they want to see what's happening to their business and what's happening to their customer loyalty rewards system, given the fact that they're competing heavily with Amazon. So that's an example of a supermarket chain that has also gone online. Game analytics. This is a large gaming developers platform where it helps developers who are coming up with games to analyze their usage data to make informed decisions, right? They can calculate important KPIs for developer titles, right? So you can see over here, you have a lot of data coming in via, in this example, they're using it's an AWS stack, and they're collecting data via Kinesis for real-time ingestion and also Elastic MapReduce. And what they're doing is they're indexing that into the Druid cluster, and the Druid cluster is giving out the results for the developers. So the developers can see the pattern, right? The developers can see as they make changes, how the users are responding to their games. Are they getting more popular or are they getting less popular? And of course, apart from that, they also, if you notice, the developers also allow advertisers to advertise within the games. If they're playing a car racing game, they can see the ad billboards in the background. So they also provide that capability to the developers. So they can analyze the usage data. They can also sell it to their advertisers. Airbnb, everyone must have used Airbnb sometime. And again, as you can see here, they are slightly different. They are streaming the data via Kafka into Spark, right, to run a bit of machine learning algorithms in there. And then they feed that into the Druid cluster, right? And again, from there, they can see it powers multiple dashboards for real-time monitoring of infrastructure and application, right? And their user activities can be seen for searching, booking, messaging. They can handle the actual infrastructure and application that supports those user behaviors. Large technology company talks about how Druid is powering their application metrics to give the users the viewing experience. Here you have all the data coming in via Kinesis. They're using the Lambda architecture, and then they're feeding it into Druid, which powers this technology company's front end, which is basically they sell it as a service to their customers. So their customers can see views, clickstream events, application metrics, and exception logs. And you can imagine they have a lot of concurrent users and a lot of customers who are paying for this service. So when the customers are paying for your service, they actually need to make sure that the system is stable, and Druid is powering that. Last but not least, Lyft. Lyft is similar to Uber. It's a ride-sharing solution. Some of the queries that they're using, as you can see, they're using a lot of option here. They're using Kinesis, they're using Flink, and they're feeding into Druid. And then Druid is used to power their front end, where they can see what's the new pickup location affecting usage, right? Was the new promo deployed in region effective? Detects anomalies in, if there's conversion is low in region, supply is lower than usual. That's example of how Druid is powering Lyft for their ride sharing use case. Now, most importantly, resources. You have a few options available for you to go and try Druid, to believe it, right? You can download the open source distribution from that website, druid.apache.org. Or if you want, you can also try the premium imply supported Druid from imply.io.getstarted, where it gives you a 30-day free trial. So you can have one of the other options. The imply option comes with the whole manager and alerting and pivoting, which comes built in. So you just get one solution out of the box, whereas the open source solution requires you to do your own integration and your own visualization, and of course security. Some of the resources that are available are on this link here. I'll share this with Harmeet, and hopefully she can share with you guys, but these are some of the available resources out there. And if you're already using Druid, then you can add that to your LinkedIn profile. Now, we are supposed to have a virtual Druid summit this year. Hopefully towards the end of the year. If most of you are like me in Australia, we won't be able to travel anywhere. So I'm pretty sure they'll run it virtually out of the US. We'll have speakers from some of our popular customers. We had the virtual Druid summit last year in April, and these are some of the users down here that presented, and you can listen to them. It's all available on these websites here. So again, I'll share that links with you guys later on. And we're off to Q&A. So what I'll do is I'll just select this. All right, so okay, I'll stop sharing and I'll just read the questions out. Okay.
Yeah, I think for the first question was, can you give an example of cold data?
Yep. Look, cold data is anything that's like, some data that is older than 7 days. Usually it's cold data. Cold data is usually used for historicals, right? When someone wants to, for example, a data analyst wants to run some SQL syntax, SQL commands against how the business is performing today to 30 days ago or 100 days ago or a year ago, that data is cold data, right? And usually they tend to run really advanced SQL syntax on it, right? SQL queries on it. So that's example where usually if it's that much of historical data and you might only have a couple of users, Druid is not suitable for that. We can do it, but quite frankly, there are already ready-made solutions out there that you can already use. How is Druid different from Impala of Cloudera Hadoop? Well, what we are seen as is more for the slicing and dicing where users need to drill down further, right? We are able to allow the users to go drill down further, allow the users to analyze further, and most importantly, able to handle at a large number of concurrency, right? Matter of fact, Cloudera themselves, as they bought the company Hortonworks, they are using Druid as one of their solutions. So there's a lot of Cloudera deployments out there without utilizing it. They actually have Druid in there. Under the IoT situation, how to distinct count the device ID from a huge data set? Well, again, we have a lot of SQL commands that we support, but group by is out of the box. We also have joins, but it comes down to, basically, with the premium Druid, you also have the user authentication to ensure the rows are only given to the customer so that they only view what they can view. So that ensures that, you don't have that problem. And if Druid provides some advantage for achieving latency for the cold data, yes, absolutely. But again, it comes down to, like I said, we can use Druid for a lot of use cases, but the area that we 100% believe that we are the best, and it's the right solution is hot latency, low latency, hot data, a lot of concurrent users who want to do their own drill downs, right? Yes, there'll be recordings. Users can write queries with a lot of table joins. Document indicates only left in it. Yep. Okay, fantastic question, right? Now, Druid, we can do joins, no doubt about it, but we are not designed to be your ETL solution, right? You will already have an ETL solution out there. You got Apache Spark, you got Apache Hadoop, you have, other ETL solutions ready-made for that. We're not in there to Druid is very, very uniquely designed for use cases where you want to power analytics to the users. You want to give the users to have the analytics. So we recommend you do your ETL, your joins before the data hits into Druid. Or if you really want to do it within Druid, you can, but then it will impact a performance. That will cost, again, it comes down to, how you want to, what is your key play here, right? Okay, implied rate, different supersets. So Imply is a company, right? So Druid is the engine. Imagine you buy a car, Imply is the car. When you buy Imply, you get the engine called Druid, you have all the other additionals, right? Superset is primarily just a visualization tool, which you can link to Druid, right? Imply is a full package solution where you get the administration and the support and there's something else that we call clarity, which it's the tuning of the engine, right? That's the difference that Imply brings to the table. And of course, the founders of Druid are the founders of Imply. So, we have a lot of other capabilities, including security, that we include in Imply Druid. Would be good tool for defining calculation metric. What do people use for inside BI? Great question. Some customers actually get Druid to support their BI tools that they already have. For example, they might be using Tableau or Power BI. Druid is in the backend connecting via JDBC. That's an example when the number of users who are connecting to the BI tool is only a handful. But if they want to expose information out to more users, then that's when the power of Imply Pivot comes in. How can we make cold data to hot data? Well, hot data starts and then it's like a cup of coffee, when you boil it, it's hot, and then as the longer it goes, it gets colder. So similar to that. Airbnb, yes, I already explained. Great question. Not yet on NBN yet. We're still working to them. We're working through them, and okay. How to this summary data of Druid cluster to this? How to get this summary data of Druid cluster of this? Summary data of Druid cluster of this company. Well, I think you can join the Druid community and post questions, and I'm sure you'll get some answers about people who work with those companies. While we're getting data from Kafka using PubSub, will it be possible to use data for real time? Yep. Well, same time right into Hive table, right? Well, most customers, they're using the ones that we have discovered, they use Hive up to a point where they can't handle the amount of concurrent users, and that's where they use Druid, right? So the moment you hit that point where you can't handle the performance expected from Hive, Druid comes into a situation. So we've had customers who had Hive was great for like 5, 10, 15 users. Moment they go above that, it takes about a minute, 2 minutes for the response time, and that's where they have gone using Druid. And those are actually Cloudera customers. Okay, fantastic question. How Druid is different from KSQL DB and Confluent Kafka? We are not like them at all. We don't do, look, KSQL does the ETL, right? It helps you run a lot of SQL commands on Kafka streams. We are a receiver of Confluent Kafka, right? So we subscribe to the topic. As much as we can do some joins, but that's not what Druid is designed for. We are actually great buddies of our friends at Confluent, great buddies at our friend Kafka. We actually tell them, do your magic with Confluent KSQL. We will be the receiving layer, and we can actually allow the users to run their analytics on top of it. Okay, we have some questions. Yep. Wow, okay, that's fantastic. So I think I've gone through bulk of the questions here.
There is one more. Can you design star schema for Druid, or it's better big table with facts and dimension? I think it's more talking about uh, uh, sort of, yeah, ETL sort of thing, or
Yeah, correct. Correct. Look, I think it's better. It's a better big table with dimensions. We can design star schema, but it's not what it's designed for. Again, like I said, the whole idea is to use Druid for the hot use cases. When you have a lot of concurrent users and a lot of analytics required on hot data, and you want to compare that to real historical data, right? That's the power of Druid. Fantastic. So are we good?
Yeah, I think so. I also had that KSQL question. So for my sake, Jag, probably I'm a bit, for the clarity perspective, would you?
Yep.
So I understand that it stands between, we just take an example of Kafka, there's Kafka, you subscribe to that topic. We don't do SQLs. I mean, Druid doesn't do KSQL or something, and it doesn't do dashboarding. So somewhere in between it stands. So would you be able to give a specific example of a real example that, okay, you got this sort of table from Kafka, then how that sort of analytics and visualization?
Yep. What I'll do, I wasn't planning to do a demo, but I'll just share a quick demo of Druid on my screen. So if you can see my screen right now, this is a Druid console, right? And basically it's running on my local machine. And when you go into Druid, this is the console, these are the connectors that you can connect to, right? Out of the box. So what I'll do, I'm going to connect to a Kafka topic, right? So I'll select Kafka, and out of the box, I'll just select the name of the bootstrap of the server. So I'm running Kafka here on my local machine. And what I'll do is I'll just subscribe to my topic. In this example, I'm going to subscribe to the Wikipedia topic, right? Because it's real time. It's happening as you and I are talking right now. Immediately, it's connected to my Wikipedia topic on my Kafka server, right? And you can see this is a raw data in there in JSON, right? So what I can do next is just go and pass the data, right? And immediately, if you remember, I was telling you the dimensions. So what it's doing, it's picked up all the dimensions from all of the rows, right? You can expand that, and you can see that's the data, right? The type of dimensions that are coming from the Kafka, from the Wikipedia Kafka topic, right? So I can see, all right, and it's already broken that out for each of these row, right? I can scroll further to the right. I can see, all right, these are the extra columns. It's automatically saying the format, right? You can see the formats, JSON, CSV, some of the formats that are available, right? This is automatically JSON, right? I'll click on apply that, and then you can go to the passing the time, right? And again, what Druid has done, it's picked up the column which has got the timestamp, right? And it's picked up the column over here. That's the timestamp column within the Kafka from this raw data for each of these rows. And you can say, all right, that's the format, right? It's in ISO, right? But you can select and modify the formats you want, right? And all other formats that's available. And then you can go down to the part where you transform, right? You can do basic transforms here, right? So like I said, you can say, all right, I see all these columns in here, right? Which are the fields. I can just say, all right, add a column transform, call it, Melbourne, right? And then just change add the expression. So I found to say, let's include deleted and delta. So I'll just say deleted, right? Plus delta, then I'll apply, right? And then now what's done, it's created the new column called Melbourne, right? And it's added those columns, deleted and delta. That's just basic column transformation if you want to do it here. And then you can filter out the rows of events here. Sometimes, people do not want to have certain number of rows from 100 to 200 or 100,000 to 200,000 for any reason. I'm not doing that here. And then you can check for the schema if you're happy with the schema that Druid picks up from your fields, right? And then you can see, okay, all that it's perfect, right? If you're not happy, you can modify it. You can do a few other changes here if you want. You can change the query granularity, etc. I'm happy with what I'm seeing, but you can modify this according to your data, right? And then you can go down and create the partition, which is the segment granularity. Again, these are the options available. Remember, I was telling you how the data is partitioned by your time period. So I'll just go with hour, which is quite consistent because of getting data in real time in seconds from Wikipedia. And then I can just say, all right, just, tune it, say, all right, the Kafka topic, there's no overlay, further tuning here if I have to, and then I can just publish it, give the data source name, right? And then edit spec and submit it. When I do that, what's happening is now it's taking me to my supervisor, which shows me, all right, the Wikipedia topic is being pending. And if I do another refresh, now it's running. And the data sources are appearing in here as we speak. So if I do a refresh, there you go, it's running over here, right? So just like that, the data is already available in my Druid server, right? The next phase is where the difference comes in. All right. So for example, if I were to say, select, say, let me just go into file, new tab, right? And say, go to this takes me to my imply. This is the difference between imply and open source Druid. Imply creates, gives you the visualization where you can start creating the dashboards, right? So I just took a look at the Wikipedia traffic. So I can come in here and say, all right, that's an example of some user interface that comes out of Imply Pivot, right? So if you're a customer of Imply and you buy Imply Druid, then you get access to ready-made data from Druid, right? And then you can go in here and say, all right, these are the type of dashboards. I can drill down. For example, I can see top users over time. If I drill down into that, I can see, all right, that's already filtered. I can modify it. I can say, let's change that to say line chart, for example, right? Or, tree map if I want to. That's an example of what users can do. If I can change that to page to see what's the current page that's popular, right? I can see, all right, there is some Spain at the Summer Olympics, Airbus A320. All this is happening in real time. It's coming from Wikipedia. So hopefully that answers your question.
Yes, Jack. And one more question. What about the storage? I mean, retention of the data and storage.
Yep. Look, remember when I was telling that, you can have coal and, you can have historicals. So what customers tend to do is they tend to, or when you architect Druid, you tend to ask how much data you expect in a day, right? And then based on that, we ask how long, for example, what are the most of the queries that you run, what is the most amount of duration, right? Some people will say 7 days. So based on how much data you're going to be ingesting in a day and how many days, we do a lot of compression too. So based on that, you can have the disk size proportionate according to that requirement.
Sounds good. Thanks, Jack. Are there any other questions? Feel free to unmute yourself and ask questions if you have any. Okay, I think I'll consider silence as all good. Yeah, thank you so much, Jack, for the talk. And it was, I think, really, really awesome and good learning experience for me. I hope that everyone found the same, have same thoughts. Okay, so now we have the marketplace. So you have, like, if you are looking for a job, or if you are someone who are a recruiter and have a job, you would want to advertise, or looking for people, then feel free to unmute yourself and share with the audience. Or maybe if there's any open source where you would want people you're working on, you would want people to contribute, or if there's any other meetups you would want to put share with the audience, or conferences, that this is the platform. So yeah, feel free to unmute yourself and share.
Hi, Harmit. It's Aisha from Monash University. Actually, I don't have anything to advertise, but I want some help from the panel session members, if someone can. Maybe you as the organizer can best describe the situation, because this is my first meetup. So I'm actually working as a research software specialist in the energy domain, and primarily developing smart energy solution for the managed microgrid as a part of net zero project. Because I did my PhD from Monash University, and I have experience and skills from IT industry, but in software engineering. I'm not data scientist, not a data analyst, but I want to start because as a part of my current job, I'm working on developing data engineering pipelines as well.
Yeah.
So I'm a bit concerned. Sorry,